hadrons are a group of particles composed of quarks. Hadrons can either be baryons or mesons. And it says, what property defines a hadron? Now, hadrons, as we know, are non-fundamental particles, which are comprised of quarks. So we know that hadrons are comprised of quarks, and that these are particles that experience the strong nuclear force. Okay, so hadrons experience the strong nuclear force, and they're also made of quarks. But for the mark, you just need to say experience strong nuclear force. So what is the quark structure of a baryon? Now, we should all know now that a baryon is made up of 3 quarks, okay? So this is made from 3 quarks. And then it says, what's the quark structure of a meson? Now, we know a meson is a quark and an antiquark. So it's simply a quark plus an antiquark. And the next one says, what one similarity and one difference between a particle and its antiparticle? Well, we know that a particle and its antiparticle have the same rest energy, the same rest mass. Okay, so we could say the same mass. And we could also say a difference between them is they would have opposite quantum states. So, for example, they would have opposite charges, for example. And complete the table below, which lists the properties of an antiproton. Now, a proton we know is up, up, down. Now, we know it's up, up, down because it's 2/3 plus 2/3 minus 1/3 to give a +1 charge. So the baryon number we know is -1 because its quark structure is the opposite to that of a proton. So instead of being up, up, down, it's anti-up, anti-up, anti-down. And the charge on the antiproton, well, we know the charge on a proton is plus 1.6 times 10 to the minus 19. So the antiproton must be minus 1.6 times 10 to the minus 19 coulombs. And the next one states, the chion minus is an example of a meson with a strangeness of -1. The chion decays in the following way. State with a reason what interaction is responsible for this decay. Now, we know that the chion has strangeness in it. So this chion here has got a strange quark in it. However, there are no quarks here and no quarks here. So we know that this must be a weak interaction because strangeness is not conserved. And strangeness is conserved with a strong nuclear interaction. So we know it must be a weak nuclear interaction. And our reason is because strangeness is not conserved. And then it states, state 2 properties other than energy and momentum that are conserved in this decay. So for example, there's no baryon number here, there's no baryon number here or here, so baryon number is conserved. And if we look as well, the muon has a lepton number of 1, the antimuon has a lepton number of -1, the chion's got none, so lepton number is also conserved. Okay, so that was a very straightforward question really on the properties of particles.